This is going to be our flipped classroom on separating mixtures. So we've already discussed that a mixture is when you have two or more substances that are combined physically, not chemically, so that they can be separated relatively easily. But depending on the type of mixture, there are different ways to separate them. I'm going to list 5 different separation techniques that you'll have to learn, understand, and memorize the vocabulary for. So the first type of mixture is where you have something like salt and water, a solution, a homogeneous mixture where you have either a solid dissolved in a liquid or a liquid dissolved in a liquid, or anything where something is evenly mixed and you want to separate them. So let's say I said to you I have salt water and I want to separate the salt from the water. What would you do? Well, the obvious thing would be boil away the water. That would definitely work. The water would evaporate and then you'd be left with the salt. However, what if I wanted to capture both the salt and the water? So, going on that theme, the term we're going to use is called distillation. Distillation is the process of separating a solution by boiling away the water, but then recondensing it back into a liquid. So it's very similar to just evaporation, except you want to keep the water. And there is a technique we use in distillation called a distilling apparatus. And I'm going to show you what that looks like. Right here is a still. As you can see, the water in this container is being heated, and that makes the water evaporate and turn to a gas. Then as it turns into a gas and leaves and goes higher and higher up to the top, it starts to cool down and become a liquid. Then gravity does its work, the liquid falls down and gets recollected, and there you have your pure water. So when you're done, all you have left in the original container is salt. So that is what distillation is. And as you can see, distillation is based on boiling points. As long as the two substances have different boiling points, you can separate by distillation. However, let's say you had something like sand and water, something that is heterogeneous. You could still use distillation, but there's a much easier way. All you'd have to do is filter the sand from the water by pouring it through, let's say, a filter paper, some sort of strainer, where the particles couldn't go through. Then the water would go right through, but the solid will remain on top. So here's what filtration looks like. You pour your mixture in there, like sand and water. The water goes right through, but the sand stays on top. It's just as simple as using a coffee filter. Another technique that could be used is called chromatography. So let's say I had something like purple ink, which actually is just a mixture of blue and red ink. Now, clearly there are two different substances, but you can't separate it by filtration because it's a solution, it's evenly mixed. You can't separate it by distillation either because they have the same boiling point. But later on in the year we're going to learn something called polarity, and that's pretty much how well it sticks to other substances. So here's what chromatography looks like. Sorry, excuse me. Right here on top, you put your chromatography paper. That spot right there is the mixture of the two different inks, or in this case 4 different inks. And then as the solvent goes up the beaker, it pulls out the substances, but they separate out depending on their polarity. Another technique, something that's used in biology, is called centrifuge. Centrifuge is based on particle density. So in other words, it's a device that spins around very, very fast, and the most dense particles go to the bottom, where the lighter ones stay to the top. And the final one I'm going to mention is very simple. It's magnetism. If you had, let's say, iron mixed with sand, and you want to separate the iron from the sand, just run a magnet over it, and voila, you have your two separated substances. All right, that is our lesson on separating mixtures.